Today we're going to look at something called expected value. We're going to start with the spinner game, spinner give and take. Suppose Braxton and Kristen are playing a game in which Braxton gets $4 from Kristen if the spinner lands on his shaded region, and Kristen gets $1 if the spinner $1 from Braxton if the spinner lands on her non-shaded region. Who do you think will win more money in the long run if they play, Braxton or Kristen? So here's an example of what the spinner looks like. Again, if it lands on Braxton, he gets $4 from Kristen. And if it lands on Kristen, she gets $1 from Braxton. So let's talk about how we can set up something called expected value, or what should happen in the long run. So again, I'll write up the definition first of expected value. I'll do that in blue. So expected value, no, maybe I'll do it in green. Expected value do this many times and average the results, what you can expect to happen. So what will happen, what you can expect to happen in the long run if you do many trials. All right, so we're going to figure out expected value. Let's do it for Braxton first. So for Braxton, the probability that he will get $4 from Kristen every time you do the spinner would be 1/4. Again, we can divide this spinner into 4 equal parts right here. So he has a 1/4 probability of earning $4 from Kristen. 3/4 probability of having to pay off or lose $1 every time the spinner lands on Kristen's non-shaded region. So if you calculate that in the long run, he'll earn about 25 cents per spin. Let's take a look at Kristen's expected value. So Kristen has a 3/4 chance of earning $1 from Braxton every time she spins, but she also has a 1/4 chance of losing $4 every spin. And if you calculate this number in the long run, on average, she will have to pay out about 1/4 per spin. So again, expected value is in the long run. If you do this many times and average the results, on average, Braxton will earn about 1/4 per spin, and on average, Kristen will lose about 1/4 per spin. Again, if you did this trial many times and average your results. So expected value, what you can expect to happen in the long run if you were to average all your results. Let's take a look at another example of expected value. We have Aunt Zena at the fair. Aunt Zena has gone to a weekend fair that her nephew's school is running. The school is trying to raise funds so they can offer some special classes. One of the games that Aunt Zena likes is ring toss. The goal is to toss a large ring so it lands on a stick. Each time Aunt Zena succeeds, she wins a coupon donated by a restaurant for a free dinner. She figures the coupon is worth about $12, and it costs Aunt Zena $1 for each toss. On Saturday, when Aunt Zena played this game, she was only able to win about once every 20 tries. If she continued like this, would she win or lose money in the long run? What would be her expected value per toss? Well, she wins once out of every 20, about 1 out of every 20, and when she does win, the value of her earnings or winnings would be $12. That means she loses about 19 out of 20 times she plays the game, and the cost of play of the game is $1 for each toss. So this expression represents her expected value, and then we can solve that, and in the long run she loses about 35 cents per toss. So again, if you were to take all her winnings and losings and average them, divide by how many times that she plays, she would lose about 35 cents per toss in the long run. Aunt Zena went home that night determined to do better the next day. She practiced and practiced, and Sunday she went back to the fair. Now she was able to win once every 10 tries. If she continued like this, would she win or lose money in the long run? What would be her expected value per toss? So again, she's now winning 1 out of every 10, and she'll win that $12 dinner coupon. So 1 out of every 10 times 12. But she still loses 9 out of every 10 times, and again she's still paying $1. So if you calculate that in the long run, she's actually going to come out ahead about 30 cents per toss. So again, in the long run, if she took all her winnings and earnings and divided by how many times she played, it would average to about 30 cents per toss. You can represent expected value many different ways, so we'll take a look at different representations. The first one we'll look at is called the carrier's payment plan. In some places, newspapers are delivered by a newspaper carrier who has already paid for the papers. The carrier then collects from the customer and keeps whatever he or she collects. Suppose one day a customer says to the carrier, instead of collecting the usual $5 a week, how about if you just pick 2 bills at random out of this bag? You get to keep whatever you pick instead of the $5. If you choose to pick out of the bag, you'll do that from every week now on. Let's use an area model or another method. We'll use the area model to compute the carrier's expected value from the alternative payment plan. That is, find the average the carrier would expect to get per week in the long run using this payment plan. Based on this theoretical analysis, decide which is the better choice and explain your decision. So here's the alternative plan. The alternate plan. The customer shows the newspaper carrier the bag, which contains 1 $10 bill and 5 $1 bills. Thus, 2 sums are possible, $11 and $2. Of course, the customer will put in new bills each week to replace the ones that should be taken the week before. All right, so we're going to figure out what's better, taking $5 a week or choosing 2 bills from this bag. And the bag contains 1 $10 bill and 5 $1 bills. Here's what an area model looks like. An area model can be used whenever you're doing something twice, like rolling a die twice, picking from a bag twice. And you can do it whenever you're picking from something twice because the first draw would be like the top of this area model, and the second draw would be the side. And again, your choices are $10 and 5 $1. So here, this represents the first draw, and this represents the second draw. And again, you can use this area model whenever you're doing something twice, drawing money twice out of a bag, rolling a die. Remember, we made the same diagram for when you rolled a dice twice. All right, so here's what the area model looks like. We've also done this model when we've multiplied polynomials. So whenever we're doing something twice, we can do this. Okay, so I'm just going to fill these boxes in with the different values here. If you draw 10 out of the bag, the 10 will not be available for the next draw. So I'm going to cross out this box right here. Same with this $1 bill. If you draw this $1 bill out of the bag, it will not be there for your second draw. So consequently, we can shade in all the diagonals here, and that just represents we're not putting that dollar bill or $10 bill back into the bag. All right, let's fill out the values for the rest of it. So we can either earn $11, or we can earn $2. Let's figure out the expected value for this alternative payment plan. All right, so we're talking probability here. What's the probability that we're going to get an 11? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 11s out of, and if we count how many boxes are open, there's 30 boxes. So there's 10 chances out of 30 that we're going to earn $11. Plus, count how many 2s there are. There's 20 out of 30 chances we'll get the $2 bills. So this will be our expected value in the long run. So we want to figure out, is this expected value going to average out to be more than $5 a week? And if it is, why don't we choose that instead of our regular $5 a week? And if you calculate this, we actually get the same amount. So the long run, the same amount over time will be the same. Okay. Let's go over, there's one problem on your assignment where it says, what would be the expected value if you were to choose only one time? So the expected value if we're only choosing once, so drawing once out of the bag. And if you're drawing once, you can't use the area model because you're only choosing one time. So if we're drawing once, this is a separate problem. What is the probability if you're drawing once? Then we would just look at one of these of getting the 10. Well, there's a 1 out of 6 chance that you're going to get the $10 bill if you're just choosing once. And there's a 5 out of 6 chance that you're going to earn $1 if you're just drawing once. So the expected value if you're just drawing one time out of the bag would be $2.50. And I think you have a problem like that on your assignment. So you can only use the area model if you're drawing twice or rolling a die twice or picking something twice. Let's do another example, the last example of an area model where we're doing something twice. So there's this game in basketball you can play called one and one. One and one is you make a shot, a free throw, and if you make that free throw, you get the opportunity to shoot again. If you miss the free throw on the first time, then you're done. So it's called the one and one. Again, if you make it, you get to play one more time, and if you miss, you're done. So DJ makes 80% of his free throw shots. Fill out this area model, and again, it's the area model because we're shooting twice. We're potentially shooting twice. And then calculate his expected value of playing the game over time. All right, so if he makes 80% of his shots, take a look at this area diagram. We split it into 10, so 10 and 10 because that's easy to do with percentages. And if you make 80% of your shots, that would represent 80 of these boxes. So this one right here, if it's 80 of the boxes, I'm just going to count over 8 because again this is 10 by 10. So 1, 2, 3, 4, 5, 6, 7, 8. All right, this rug diagram right now is 100%. The whole thing's 100%. But there's an 80% chance here that he makes his first shot, and there's a 20% chance here that he misses his first shot, and if he misses, he gets 0 points. All right, if he makes his first shot, so this right here, he gets to shoot again. And again, remember, he makes 80% of his shots. So I'm going to erase this, and again, remember, this is the percentage that he makes it, and we're going to take 80% of 80. And to do that, again, I'm just going to count 8. So again, here's 10 boxes, and I'm going to count 8 of them to count for 80% of 80. So 1, 2, 3, 4, 5, 6, 7, 8. Draw this line right here. So again, he's making 80%. So here's his second shot. This part right here represents his second shot. And if we count, this is 8 by 8, or 64%, that he gets 2 points. If we count this, it's 2 by 8, and 2 by 8 would be 16, or if we count the boxes, I'll use a different color. There's 16% chance that he'll make the first shot but miss the second, so 16% that he gets 1 point. So the expected value will be your probability times your payoff. So the probability is 20% chance that he gets 0 points. Plus, he has a 16% chance of earning 1 point, plus he has a 64% chance of earning 2 points. So when you calculate that, that's expected value over time, and the answer that you get is 144. And what that means is, on average, if he played this one-on-one situation many times and took all of his points and divided by how many times he played, he would on average shoot about 1.44 points per game, so a little bit more than almost 1.5 points per game. So let's try this one-on-one area diagram one more time. So let's say we have Samara here, and Samara makes 60% of her first shot. If she makes her first shot, then she makes 80% of her second shot. If she misses her first shot, she's done. What's her expected value? So again, we have this 100% right here, and for Samara, she makes 60% of her first shot. So I'm going to do 60%, count 6 boxes, 1, 2, 3, 4, 5, 6. Okay, so this is 60% chance that she makes her first shot, and she has a 40% chance that she misses her first shot. And if she misses, she's done, and she gets 0 points. But if she makes it, she gets to shoot again. And now she makes it. She makes 80% of her second shot. So let's count down 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this over here, this represents that she makes her shot. And if she makes it, she makes 80%. So let's count this. This would be 8 by 6, which is 48% chance that she makes both, and that would be 2 points. Down here, if we count, there's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12% chance that she gets 1 point. So our expected value is probability times payoff. So probability is 40% chance she gets 0, plus 12% chance that she earns 1 point, plus 40% chance that she earns 2 points. So when you calculate this, and I haven't done this calculation yet, you want to try to figure out what is her expected value in the long run. How much would she on average earn? How many points would she earn if she played a long time? So you have problems like these on your assignment. And remember, if you're doing something twice, you can use the area model. If you're doing something once, then you just have to figure out probability times payoff. So you have several problems to try on your assignment, and we'll go over this tomorrow.